Students, this is the help video for the ALEKS problems in preparing for the Unit 5 trigonometry test. So in this problem, we're going to solve for the variable, and you're going to have to watch for something very, very important here. So taking a look here, if you were to solve for x, your goal is to get x by itself. So you work backwards PEMDAS. So you do addition and subtraction first. So we have here x plus 10 equals, that's going to be -6. And then you do multiplication and division if there is any. And there isn't at the moment because we have to deal with the exponent here. And the exponent is the opposite of square rooting, is squaring. So when we square this, it undoes the radical there. So we have x plus 10 equals -6. And we minus 10 both sides. You get x equals -16. Now, the problem with this is if we put here -16 plus 10 underneath that radical sign, we end up with root -6. You cannot square root a negative number without going into something called imaginary numbers. And notice we're limited to what's called real numbers. So you cannot square root -1 because any number times itself is automatically positive. So technically, -6, the square root of -6 is this notation. It's an imaginary number times root 6. And since we are limited to real numbers, basic rule is this: when you solve for x here, if the value of x underneath a radical sign ends up being negative, then on ALEKS, let me show you what this looks like on ALEKS, is you click on this button that says no solution, because notice they limit you to what's called real numbers. You're going to hit what's called imaginary numbers next year. So we take a look here, we have a right angle, and if you have two sides, need third side, Pythag. So right here, we're doing leg squared plus leg squared equals hypo squared. It's unknown squared. Now, a lot of you are grabbing your calculators at this point, but I'm going to show you a little shortcut so that you can do the entire thing in one step. I'm going to go ahead and minus the 30 squared both sides. So you have x squared equals 37 squared minus 30 squared. To undo a square, you square root both sides. So we have x equals the square root of 37 squared minus 30 squared. I'm going to show you how to do this in one step on first the ALEKS calculator and then your TIs. So on the ALEKS calculator, it's going to look like this. All right, take a look here. Square root of 37 squared minus 30 squared. So you grab this, and you do 37 squared minus 30 squared. You can do that in one step on your calculator, and then it'll round to the nearest tenth. On your TIs, it looks like this. You can do second function square root. Hang on, that seems to be, there we go. 37 square root, 37 squared minus 30 squared, enter. Notice you're getting the same thing. You check your thing here, and it's usually round to the 10th place on ALEKS, so it's 21.7. Let's double check that that's what it wants. And it is, so we do 21.7, check for units. Meters is your X. So here we're doing 45, 45, 90, 30, 60, 90. The first one is 30, 60, 90, short leg root 3, short leg times 2. So it looks like this. We start with the short leg to long leg, root 3, short leg to hypo, times by 2. So in this case, something times 2 is 8. Your something here is going to be 4. And then if it wanted the other side, it would excuse me, I said 4, wrote 8, 4. And then this would be 4 root 3 if you were asked for that. 45, 45, 90, leg, root 2. Legs are equal. Hypo is whatever the leg is times root 2. So it reads like this. Something times root 2 is 3. So you just work backwards here. We know you need a root 2 there. That's going to get us 2. You know you need a 3 there. That gets us 6. To get back down to 3, we need to divide by 2. So the final answer would be 3 root 2 over 2 for both of them. Now in this one, we're going to be using what's called the test for acute, right, or obtuse angles. Acute, right, or obtuse angles. So you apply the Pythagorean theorem, leg squared plus leg squared equals hypo squared. So right here, we're doing 7 squared plus 24 squared. On the ALEKS calculator, 7 squared plus 24 squared, that equals 625. And that is going to be hypo squared equals 625. And to solve for that, you do the square root and you end up with 25. Now it says compute the square of the longest length here. And that's 625. Since the longest length does fit the Pythagorean theorem, we would say that this is a right triangle. In other words, if you put the numbers least to greatest into the Pythagorean theorem and it works, behold, you have a right triangle. Take a look here. We're going to take the short side and the medium side and see what that equals. 9 squared plus 10 squared. Of course, that's going to be 181. And our longest side is 16, and 16 squared is 256, but I'll just show that to you anyways, because I have my perfect squares memorized through 20. And that's 256. So what you're noticing here is that the longest side is not equal to the square. The square of the longest side is, it's like this. The smallest side squared plus the medium side squared compared to the longest side squared. And right here, instead of an equal sign, which would make it a right triangle, the longest side is larger squared. We would say, therefore, it is an obtuse triangle if the longest side squared is larger than the other two sides. If it was like this is obtuse. If the small side squared plus the medium side squared, if that is greater than the longest side squared, then it would be acute. Okay, it says we have lengths here and that it is a right triangle. And it wants you to find the sine of y. Notice it says specifically y. So we're going to sweep y. That tells you this is the opposite. This would be the adjacent. This would be the hypo. So this first one, sine of y, is going to be opposite over hypo. So the sine of y is the fraction, in this case, 24 over 25. You leave it alone. You don't even have to put it in a calculator. It just wants the fraction. Just wants the fractional form of the ratio. Tangent of y is OA. So that is opposite over adjacent. In this case, the opposite, of course, is still 24. The adjacent is 7. Ta-da! Leave it. That's all you need. Third one, cosine. That's adjacent over hypo. Adjacent in this case is 7. Hypo is 25. Again, leave it. It just wants the fraction. That's all it wants. Here it says solve for the right triangle, round your answer to the nearest tenth. So we're going to solve for every unknown. And the simplest and first unknown is angle B. So notice on ALEKS, it'll have that degree symbol there. When you solve for the other angle, you simply take it away from 90. So angle B in this case would be 46 degrees. Now you need to choose an angle to work with. I tend to just start with the angle that was originally given, just so I don't confuse myself. So from there, I'm going to label, this is opposite, this is adjacent, here's your hypo. Now I'm going to go for side length B first. Side length B, I have an AH combo. An AH combo. Right here. To get B, that's going to be an adjacent and a hypo combo. So it's So it's cosine, and it's a side length, so it should look like this: cosine theta over 1 adjacent over hypo. Now you circle plug chug for theta, cosine 44 equals adjacent variable lowercase b over hypo 30. Cross multiply. And your variable is by itself, then you can grab a calculator. We're going to do cosine 44 times 30. I would do this in 2 steps. Cosine 44, enter, times 30, enter. And you get 21 point, looks like 58 there, 21.58. ALEKS usually wants you to round to the nearest tenth. Let's double check that. Yep. And so it's going to be 21.6. Solve for A. A is going to be opposite over hypo. So it's O, so sine of theta over 1 equals opposite over hypo. Sine of 44, keep parentheses around that, equals opposite, which is A over hypo, which is 30. Cross multiply. Sine 44 times 30 equals A. Sine 44. Let's test to see how this works. Times 30. Let's see if we get the same answer here. Okay, keep that in mind. 20.84. Sine 44, enter, times 30, enter. We get the same thing. So you can do it in 1 step there. And we're getting 20.8 for our A using SOHCAHTOA. Okay, this problem, we're using inverse SOHCAHTOA. So we have opposite, we have hypo, we have adjacent. And if we want angle A, we're working with O over H. We're solving for the angle, so it's inverse sine. Opposite over hypo. Equals theta. Inverse sine. Opposite is 15 over hypo 17. It's going to give us that angle theta. On the ALEKS calculator, second function sine 15 over 17. And we have 61.9 here. Degrees. All righty. So this one is a theoretical concept. So we're going to start with the sine of A. and it means angle A. So from angle A, this would be opposite, this would be adjacent, this would be hypo. Pay attention to when we change the angles. So it says right here, the sine of angle A is going to be opposite over hypo. So it has letters here. So the opposite, if you look carefully, that is a lowercase a is the opposite. And the hypo is a lowercase c. So the sine of angle A is the A over C variable. The cosine of A is adjacent over hypo. So that's going to be B over H. Now look what changes. What changes is we're changing the angle. Now we're going to do the sine of angle B. So if B is our angle, that means that's now our opposite. That's now our adjacent. That's our hypo. So in this case, the sine opposite is B over H, which is, down here, the H is not H, it's C. B over C. And the cosine of B is going to be that letter A, variable over C. Now look very, very carefully what's happening here. I'm going to take this. It's asking, what do we know about angle A and B? Well, since this is 90, angle C, A and B, the measure of angle A plus the measure of angle B has to be 90 degrees. That means they're complementary. Complementary adds up to 90 degrees. So right here, angle A and B are going to be complementary. Now watch carefully. Bringing this down so it's easy to see. It's asking what's true here. If you look very, very carefully, what's true? See A over C? Let's match them up. If the highlighter cooperates here. The sine of A, notice it's A over C. Pen has a little bit of a lag here. There, okay. The sine of A is A over C, which is the same as cosine of B. So the sine of A is the same as cosine of B. So this would be a true statement. Right here. Sine of A is the same as cosine of B. That's a true statement. Also notice that the sine of B is the same as cosine of A. That makes this also a true statement. So these last two are both true statements. So the sine of one angle is equal to the sine of the other angle. That's complementary. Complementary means adds up to 90 degrees. So to give an example here, the cosine of 59 degrees would be the same as sine of 39, which is its complementary angle. No, not 39. 31. Excuse me. Because 31 and 59 add up to 90. So the cosine of one of an angle is the same as the sine of the complementary angle. That's the point of that whole activity. These ones are the tricky ones. And it's a combined right triangle. Let's read the scenario together. Then I'm going to show you how to do this on the ALEKS calculator. It says, looking up, Mary sees two hot air balloons in the sky above. She determines that the lower hot air balloon is 356 meters away at an angle of 23 degrees from the vertical. The higher is 1,035 meters away at an angle of 41 degrees from the vertical. How much higher is the balloon on the right compared to the balloon on the left? So it wants this distance. How much higher is your ultimate distance here? Here's the tricky part. Do not round any intermediate computations. Your final answer gets round to the nearest tenth. So you have to set this up as one giant equation. Let's do the triangle separately. Notice here that if we solve for this from here to here, we'll call that x. And we solve for this from here to here, we call that y. Then, if you subtract those, you'll get ultimately what you want, x minus y. So let's go for x first. From in this triangle, this would be the adjacent, this would be the cosine. So watch how we set this up. Cosine 41 degrees over 1 equals our x over our hypo, which is 1,035. I'm going to cross multiply. So x would equal cosine 41 times 1,035. Stop there. Don't do the math yet. Let's come over here for y and 23 degrees. That y would also be the adjacent. In that triangle, this would be the hypo here. So cosine again, cosine 23 this time over 1 equals adjacent, which is going to be our y, over our hypo, which is 365. Cross multiply. So to get our final answer, which is the yellow squiggle, which is the difference of the two, you are essentially doing this. You are going to do the value of x minus the value of y. Now you plug in the values of those in your setup. So x is cosine 41 times 1,035 minus cosine 23 times 365. Notice I'm setting it all up because it doesn't want you to round any intermediate steps. It wants you to do the entire thing on a calculator. I'm going to write this down so I don't lose track. Cosine 41 times 1,035 minus cosine 23 times 365. We're going to do this both on the ALEKS calculator and the TI, so you can see them both. So here's the ALEKS calculator. It is cosine 41 times 1,035 minus cosine 23, that times on the outside 365. Whole thing goes in the calculator. Enter. 445.1. Now I'm going to show you on the TI so you can see that they're the same. So watch, cosine 41 times 1,035 minus cosine 23, close the parentheses on the outside, times 365. Enter. 445.1. You're getting the same thing. So that would be the value of the unknown. In this case, would be 445.1. Check for units, meters. There you go.